This is video number 2 for graphing in 3 dimensions. In our first video, we focused on what 3D was represented as in coordinate space, as well as how to plot points in coordinate space. This video, we are taking a step further, and now we're graphing planes in coordinate space. Okay, so let's click over to the tab that says planes in space. So we know that when we are in 2D, the coordinate plane, if we have an equation of the form 3x minus 2y equals 6, we know that's going to graph to be a line, right? It's a linear equation. To bring that equation into 3 dimensions, all we need to do is add in a third variable to the equation. So now I'm going to change it to 3x minus 2y plus 2z equals 6, and now that's going to graph to be a plane, okay? And of course, the plane would have to be done in 3D. Now let me give you a nice visual illustration of this. I'm going to take a second to load here. So you can see I have the exact same equation from our notes typed in the top left there. And over on the right, you can see in blue, that's the plane represented by that equation, okay? And we typically, we've seen planes represented kind of in this parallelogram fashion. Let me kind of move this around in different ways so you can kind of see how this plane has been positioned, okay? Now, trying to graph a plane in this fashion ourselves to where it looks like a parallelogram on a 2D piece of paper or a 2D screen, it's kind of challenging, okay? So instead, what we end up doing is we end up graphing it to look more like a triangle. And we do that by graphing lines, they're called trace lines, that pass through the x, the y, and the z intercepts that are associated with the plane. So let me give you a good visual of what I mean here. Okay, so there would be one trace line for this plane, and then we would also have our next trace line here, and then our final trace line. Okay, so you can see how that triangular region formed by those 3 trace lines, it coincides with that blue plane that's representing the equation. So this is actually how our planes are going to look when we make these ourselves, okay? So let's kind of find this back in our notes here. We're graphing planes in coordinate space by drawing the trace lines. So you can see this is the plane represented by that equation from above. And I've simply graphed it by just finding the x, the y, and the z-intercept. So for this equation, the x-intercept would be when y and z are 0. Solve for x, you get 2. So that's this point right here. Your y-intercept would be when x and z are 0. Solve for y, you end up with -3, which is right here. And then your z-intercept, same process, x and y are 0. Solve for z, you get 3. Okay. And once I plot those 3 points, I simply just draw trace lines connecting 2 of the 3 intercepts at a time, okay? This is known as your XZ trace, since it passes through the x-intercept and the z-intercept. This is your YZ trace, passing through the y and the z-intercept, and then this is your XY trace, okay? Let's define a trace line formally. It's a line that passes through two of the 3 intercepts of a 3D equation. And think of trace lines, they're kind of like extensions of intercepts, right? Intercepts are points, and then traces are lines that pass through those intercepts, okay? So let's move to an example we have to do completely on our own. We want to graph this plane, and not only do we want to graph the plane, but we also want to write an equation to represent each trace line, okay? So graphing the plane should be super simple. Again, all you're doing is finding the x, the y, and the z intercepts. So your x-intercept for this equation is 3. So that's the point 3, 0, 0. And you would plot that right here, 3 units forward from the origin. Your y-intercept would be -6. So that's the point 0, -6, 0. Going to kind of have to go off the line here a little bit. So from the origin, 6 units left. And then your z-intercept would be 2. That's the point 0, 0, 2, which is right up here. Okay. Once you plot those 3 points, simply connect them all with your trace lines. Okay. And you can see we get this triangular region formed. We want to shade that in. This represents the set of points that make that equation of 2x minus y plus 3z equal to 6 true. Okay. Now let's come up with an equation to represent each of the trace lines. Okay, so starting with the xy trace, right here is your xy trace passing through the x and the y intercepts. And really simple to find an equation for the trace line. Whichever variable is not associated with that trace line, you simply make that variable 0 in the original equation. So for the xy trace, I'm going to make z 0 in the original equation, and then that simplifies the equation to 2x minus y equals 6. So that's an equation in the xy plane to represent that trace line. For the xz trace, I would plug in 0 for y. That would lead me to 2x plus 3z equals 6. Okay, and that's representing this guy right here. So that's an equation in the xz plane to represent that line. And then finally, we got to be careful on the yz trace. So we'll plug in 0 for x. And initially, that's going to lead me to negative y plus 3z equals 6. But let's follow good practice here, and we always like that leading coefficient when we're in a standard form to be positive, right? So I'm going to divide both sides here by -1 and put this into true standard form. So it's going to become y minus 3z equals -6. And that is the equation to represent this trace line. Okay, so as simple as that. All right, that's it for me. You're gonna pause the video, try practice 2 on your own, follow the same process we did in this example, and then come back to the video and check your work.